Alright, how's it going, guys? Today I'm going to show you how to work with Desmos a little bit for a graphing calculator, in case you need it. I'll mainly be going through how to use it on quadratic functions, especially in standard form. So, Desmos, to get there, you just go to desmos.com on any internet browser. Just go to desmos.com. So, pretty straightforward, desmos.com. This is the home page that I'm on right now. This big button right here, start graphing. That's all you got to do. Just go right there, click it, and then it opens up the page for your graphing calculator. You got your graph right over here on the right, your coordinate grid, and then over here on the left is where you're going to type in your functions, your equations, whatever you want to graph. There's a lot of websites that use Desmos. It's already embedded into their website. So, for example, if you're using Edgenuity for your work, here's one of the questions on one of the assignments. Right over here on the side, it says standard calculator. I can click that, and it'll give me just a regular scientific calculator, just a basic calculator. And again, I did not click this, or else it'll open up a pop-up giving me a standard calculator, and I can't get that graphing one. But if I hover and then go across, the very next one says graphing calculator. So I can click on that one, and it'll do a little pop-up, and if you look right down here, it says powered by Desmos, because this is the exact same thing as what's on the Desmos website. The difference is this one's not that big for me. I'd rather fill up the whole page. Okay, so I'm going to exit out of that, go back over to desmos.com, and here we go. Now, a shortcut is right up here in the menu to the top left. You click on that. You can go down. You can choose some pre-made functions or equations for yourself. Right here, lines, that's just saying linear, okay, linear equations. Parabolas, well, if you know about quadratics, you know that it creates a parabola on a graph. So I need parabolas when talking about quadratics. Let's see, we were talking about, I said I was going to do standard form today. So right here, parabola standard form. I'm going to click on this one. Yeah, that's what I want. Looks like that, so open graph. And there we go. And over here on my left, this is what it plugged in. It says y equals ax squared plus bx plus c. In the previous video I did, quadratic functions, I talked about how this is a quadratic function in standard form. We know it's a quadratic because squared, the 2 is the highest exponent, okay, which makes it a quadratic. Okay, it's going to give us this nice little curve right here, this U shape. Or it could be, reflected across the x-axis and be an upside-down U shape. Now, it gave us sliders down here for A, B, and C. All right? And so what this means is it knows that A, B, and C are going to be variables, not constants. And so they could be any number. So right here, A equals 1. So that means this is 1x squared plus 0x plus 1. That's what equation is graphed over here. So I could change this. Let's say I increase A. What happens to the graph? Well, as I slide it and I make A greater, I increase the value of A, it makes the graph thinner over here or more narrow. Okay? It's stretching it vertically. If you remember us talking about transformations before in the school year. If I go closer to 0, if I decrease it, well, now it's getting wider, okay? It's becoming a little bit fatter on the graph. It's vertically compressing. Now, if I get down to 0, I've said before how A cannot equal 0 for a quadratic function because now it's linear. It's no longer quadratic. There is no curve because it took out the x squared. Because 0 times x squared is 0. Well, there's no more x squared. So it's just linear. The highest exponent is a 1. But if I go into the negatives, well, there we go. Now it flips it across the x-axis, and we can visualize it now. Okay, and then the further away I get from 0, the more narrow it becomes, just like it did on the top. Okay. So if your a value is positive, open up curve. It's a parabola that opens upward. If it's a negative a value, the parabola opens down. All right, next thing we can look at, let's change a couple numbers in here. Now, if you want to get an exact number, and you're not just kind of guessing like I'm doing and dragging them, you can actually click on and then go and edit it. Now, I use a keyboard on my computer, but I'll show you if you're not using if you don't have a keyboard, you can click in there and then go down to right here, show keypad, click on that, and it'll open it up for you for things that you can use. And so let's say we want to make it -4. So I put -4 there because I don't have a negative sign in here. And then for B, let's change that to a whole number. We can just keep it at 3. And then C, we'll make that one 2. All right, so here we go. So I've got it all plugged in. I don't need the keypad anymore, so I'm going to go ahead and minimize that. I want to look at my graph and kind of analyze it a little bit. Look for my key features. So my vertex is the tip of the curve. So I look at the tip of the curve right up here, and I want to know, okay, well now I need to know the coordinates of it. So I'm going to click on the graph, and it gives me these little shaded dots, but they're not dark shaded. If I want it to be dark shaded, I go to the little dot and I click on it. And now the coordinate's going to stay there for me if I move the mouse away. These, they don't stay because I didn't click on it yet. Right up here, tip of the curve, that's my vertex. It's the highest point of the curve, so it's my maximum. It's a maximum vertex at 0.375, comma 2.563. Okay, and it's that easy. You don't have to, write in any formulas to find the vertex. You just graph it, click on it, there it is. And then right here, well, that's telling you another key feature is right here. That's going to be my y-intercept because it touches the y-axis at 0, 2. Right here, I've got my x-intercepts at negative 0.425 and at 1.175. My axis of symmetry always goes through the vertex. It splits it down in half, splits my parabola in half. So my axis of symmetry here would be x equals 0.375. Okay, it's always an equation, so it's x equals, and then it's whatever the x is for your vertex whenever you're trying to find the axis of symmetry. What else can we find looking at this graph? Well, we can see where it's increasing and where it's decreasing. So according to this graph, it's going to disappear. Oh, it didn't disappear on me this time. All right. So on this graph, it's increasing because, again, you look at it from left to right. So left to right on this graph, it's increasing here, and it's decreasing here. So the increase, well, it doesn't stop here. It's continuing to the left. We just can't see it. If I go back to the website, I can drag it, and I can see that it's continuing going to the left, and it's never going to stop. So it's going to go to the left all the way to negative infinity on the x-axis. All right. And so knowing that, I know that it's increasing from negative infinity, or on the interval from negative infinity, and then all the way it keeps increasing until it gets to 0.375. That's the interval that it increases from negative infinity on the x-axis all the way to 0.375. This graph is increasing, it's going up. But then starting there at 0.375 and moving on, it's always going to be decreasing. So it'll be decreasing on the interval of 0.375 all the way up to positive infinity because it's going to keep going on forever into the positive numbers for x. Got to close that off. All right, so these are my two intervals. It's increasing on this interval and decreasing on this interval. Another thing we can look at is domain, or what are all the possible x values that would work. What x values can I plug into this, into this equation over here and always get an answer? Well, the cool thing about quadratics is all numbers for x work. So all real numbers. All real numbers are possible for the domain. Okay, all x's are possible. Now the range is a little different. The range we're looking at, well, what are the possible answers that we can get from this equation? And this equation, again, if I write it out, would be y equals, our a value is -4, and we have x squared. B value is 3, so positive 3x, and the c value is 2, so positive 2, or plus 2. All right, now the range for this equation here, well, I look at the graph. What was my y value where it stopped? Right there at 2.563. So y is always going to be less than that. All my answers are below this. Here's an answer, there's an answer. Anywhere on this graph, I can put a point on that curve, that's a possible answer. Okay? The y value for that point is a possible answer. So all of them are less than or equal to 2.563. Because that's the highest one. That was my maximum y value. So all my other answers are going to be lower than that. So for example, if I said, will there ever be an answer to this? Will this ever equal -2? Let's look at -2. Yeah, here's part of the graph, and there's also going to be, so there's going to be 2 times that this equation can equal -2. It'll equal it somewhere around -0.8 and somewhere around positive 1.5. All right, so it's 2 possible answers from this expression, or from this equation. All right, let's look at another one. Let's say we want to know, is it possible to get an answer of 4? Okay, I want to know, can this equal 4? Can I put something in for x? Can I input an x value and get an answer of 4? And the answer is no. I can't get positive 4 because this graph will never get that high. So none of the x values will ever be plugged in and get you an answer of 4. All right? And so 4 is not in the range. So it's not a possible answer. Okay, so that's what range and domain would be. Okay, again, domain's really easy. All real numbers every time. So just come in here. Let's say that you don't want to use that pre-made stuff. Again, you can just come type it out, guys. Keypad, type in whatever you need down here. Also, function notation works. So you can come down here to ABC and just type it in. F parentheses x, close your parentheses, equals, and you just type in whatever equation you need. Okay, so 2x squared minus 5. Okay, let's say that's all you needed. And close out of that so I can see the whole graph. Drag it down so I can see my vertex. Click on the graph. There's my vertex. Well, it's also my y-intercept here. It's where it touches the y-axis. There's my x-intercepts. Axis of symmetry goes down through the vertex. Okay, you got everything here. So again, graph it up. Analyze your graph. All right, that's it for today, guys.